Hello everyone, this is Prashant Saddev from Harbinger Systems. Welcome everyone and wish you all very happy new year. This is our first webinar of 2016, so we are excited to topics. We are starting this month with Internet of Things and we will cover IoT platforms and middlewares for rapid application development. First of all, maybe we can do a couple of housekeeping checks. If you can hear me clearly, I request you to please type yes in the chat box. Throughout our presentation, we encourage you to interact with our speakers, myself as well as Siley, whom I will introduce in short time. And feel free to add questions during the webinar or even any comments you have in the question pane. We will try to answer as many questions as possible during the Q&A sections, which will go after the presentation. So again, I'd like to welcome you all on behalf of Harbinger Systems. I am Prashant Saddev, leading new practice positioning at Harbinger Systems. I take care of new practice here and new practice positioning, and we have like shortlisted a couple of quite interesting areas like Internet of Things, data science, and cryptography within Harbinger Systems, where we are investing ourselves into a R&D lab, where we try to and get capability development in new sectors, as well as help a lot of new prospects for innovative product development in Internet of Things, data science, and cryptography. Along with me, we have Shaili Doshi. Shaili is an associate technical lead at Harbinger Systems with 4 years of experience in design and development of enterprise systems across mobile domain and enterprise systems. She is passionate on latest trend in mobility, and she has worked on iOS, Android, phone gap, and as well as a lot of IoT platforms which we will discuss today. With further ado, let's begin the session. Also, before we also have a special offer at the end of this webinar for all the webinar attendees, which is very surprise thing from Harbinger Systems to all our prospects this new year. Let's begin with the agenda. So we are going to cover key insights of IoT. Then we will get deeper into IoT architecture, the business needs of IoT platform. Then get into more details on the components that are involved within the IoT platform. Then we will list some key players and also talk a brief on that. And then on some of the IoT platforms, we will discuss some detailed features, limitations, and also show you some case studies which we have developed at Harbinger Systems. We will also show you one demo, and after that, at the conclusion, we will help you give some tips on choosing the right platform for your business idea. So this would be a quick key insight of IoT. Of course, we always hear from various articles that there are billions of devices which are coming on internet, but we thought to give you some different insights. And the first insight which we have is IoT for startups. Funding in IoT startups has grown at a steady clip, more than 168 million in 2010 to over 2 billion in 2014, and in 2015 it's already crossed around 2 billion, and it might break the record of 2014. So that's quite interesting for a lot of product startups who are starting into IoT sector. Within cloud, there have been like around 37.9% of IoT apps being developed on various cloud, and 50% of developers are beginning to develop in the next 12 months, which is an interesting insight. And of course, all these developers will be interested to even check various IoT platforms, which are very easy for helping them rapid application development for their own business idea. Let's get into IoT architecture. IoT architecture is very important to understand because it has a lot of interesting things besides the regular device, besides the regular mobile devices. There is now an interesting, very important component, which is device layer. So device layer nowadays can consist of different sensors which are attached to various machinery or to a car or to a logistic provider. It consists of sensors that continuously collect data from physical things, and physical thing could be anything, as I said before. It could be a machinery, it could be car, it could be transportation, or it could even be actuator that can receive certain actions like on and off, or even get some signals, analog signals that get converted to digital and send the data. Or it could also be a increase, decrease speed of some moving object. The device layer is then connected to a gateway layer. Gateway layer consists of microcontroller processor, which will temporarily store the data collected from various sensors, do preliminary filtering, and send it to cloud. So from device layer to gateway layer, there are different kind of protocols like ZigBee, BLE, which is Bluetooth Low Energy. It could be wired, or it could be a lot of other things like Wi-Fi also in some cases. In industrial setup, there are a lot of other physical device layers are connected to physical things by Modbus, and then they can then send data to microprocessor at gateway layer, which will then send data on HTTP or optimized messaging platform like MQTT and COAP to a cloud layer. So in the cloud layer, there are a lot of other components. It consists of different services and APIs to receive data from the gateway layer. It also includes data storage, which could be regular relational database or NoSQL database. It has a rule engine, which is very important for writing, creating rules, so that you can write some scripts which can run whenever they receive particular pattern of data or particular kind of alerts kind of system. The IoT Cloud also provides strong analytic platform and as well as visualization templates. Finally, they also have device management system. Many of them have, some might not have device management system. Lastly, the last component, which is the UI interface, user interface layer. User interface layer could be a regular web client, or it could be a mobile. Sometimes it could also be another machine in case of machine-to-machine interface. User interface can also have various complex dashboard, and alerts may take certain actions for actuators. So user interface also can control and send some data back to the device layer through the IoT Cloud and gateway layer. With a good understanding of IoT architecture, I would now request Saili Doshi to continue ahead for the business need for IoT platform. Thank you.
Thanks, Prashant. Now that we have a good understanding that what architecture for IoT is and what all things are included in the architecture, let's see what exactly is the business need of having the IoT platform, which will be a bit different than the standard platforms which are there for web apps. So one differentiator or the basic for IoT is that millions of devices are connected over the network. These are heterogeneous devices, and managing these devices, monitoring data coming from these devices is a big challenge. One needs to take care of its firmware updates and other things related to deployment as well. Hence, providing inbuilt mechanism for device management, maintenance, and monitoring data will ease the development, and one can focus on developing core business logic related to the product. Hence, millions of devices becomes one of the business needs to having a different IoT platform. Another thing is the diversity of data coming from these millions of devices. Every IoT app is significant and different domain. As a result, there is diversity of data collected. So sometimes you have analog data, sometimes you have digital data, So converting these data, interpreting it, and making it appropriate for the business need and useful for decision making is another task. Real-time data management of such data is key characteristics of the IoT platform. As IoT is about all real-time data, collecting data from device, storing it on cloud, and analyzing it to act and make actions for the sensors based upon these decisions is another key factor in IoT. And all this should happen quick, or rather I should say in real time. So continuous connectivity and handling the diversity of data is an important aspect for IoT application. The third need is the analytics which we have to derive out of the data which is collected. IoT is giving more volumes to the big data. The optimal use of this data is key for any business, and it has created great opportunities for analytics. If cloud or the IoT platform has analytics capabilities, this will also help in rapid application development. It also opens the opportunities for the pervasive business intelligence. The fourth need is the infrastructure management. Devices are spread over the network. Along with the devices such as sensors, there might be other devices as servers or the mobile clients if the application for it exists. So managing all these components over the network is an additional overhead, and hence infrastructure management is another task that needs to be taken care in the IoT application. And the last need is the rapid application development. In today's competitive marketplace, many are entering into the IoT business. Every one of them has unique ideas, and hence quick development of your application and entering the market Sorry for the inconvenience. Just a quick check. If you are able to hear me properly, type yes in the question pane. Seems all good. So let's continue. So the last point is rapid application development. In today's competitive marketplace, many are entering into this IoT business. Every one of them has some other unique idea to develop for their IoT product. And hence, quick development of your application and entering the market at right time is the most important success factor for your business. Using IoT for development team to quickly deploy your products in few weeks as opposed to developing the complete solution from scratch that could take months. So due to all these reasons, one needs to have a different IoT platform which differentiates it from the standard platform. So let's have a look what all components should be present in the IoT platform. So there are 5 components or basic categories we should say for the components. Out of those first is the core platform. So core platform provides the set of capabilities to connect, collect the data, monitor the data, and control the heterogeneous devices over the network. It consists of protocol gateway to enable the communication between devices supporting BLE, Wi-Fi or Zigbee protocols, and there is also messaging middleware which allows senders and publishers, or should I say publishers and subscribers, to distribute message in a loosely coupled manner. It also has data storage with support for both structured as well as unstructured data, and it can even perform the aggregation and filtering or some kind of data processing over the platform. So this is core platform. Second category is the business logic. So this consists of the SDKs for hardware devices or mobile devices, then APIs for web portals, and different services may be generic or domain specific. For example, it could be push notifications. These are consumed by the applications. It would also have ready-to-use application templates which can help in quick application development. It also has some events and services based upon which one could write the logic for it. Model is also built in with the IoT platform. The third category is security and management. So building and deploying end-to-end application is a complex process and involves many players like hardware providers, embedded devices, its manufacturers, network providers, platform providers, solution providers, and so many. So essentially, data is flowing across various components from sensors or actuators to cloud and further to mobile applications or a web portal. In such situations, maintaining security of this data is of utmost importance. To manage all this complex coordination with required security, this layer provides capabilities to manage end-to-end security considerations. The next category is analytical platform. As we have seen that analytics is one of the business needs for IoT platform, analytical platform is one of the core category for IoT platform. So it has the capability to learn and behave like human brains, or we should say analyze and have decision-making algorithms out of it. It can analyze large volumes of information, derive some insights, and enable applications to take action. It could perform stream processing, has capability for machine learning, handle different events, and generate reports to visualize it on dashboards and result in some of the graphical manner. The last category is cognitive platform. It has capability to learn and behave like human brains. So it would enable the IoT application to respond smartly to any interaction with humans through machine learning or natural language processing. This will require to have good human knowledge and reinforcement learning based upon the decisions which we are going to devise out of the data collected and analyzed. So these are the components, or I should say functionalities, which should be there with the IoT platform. With this information, I would request Prashant to continue for explaining the key players in the IoT platform.
Thank you, Shaili, for explaining the business need of IoT platform and also giving a good overview on the components of IoT platform. With this, let me get ahead with key players in IoT platform. So these are various players. Of course, these are not complete. There are many more, maybe hundreds of them. So some of them we have tried to list down on this slide. So ThingWorks from PTC, which is widely popular within the industrial IoT, and so are similar many other industrial IoT platforms. Amazon is quite recent entrant into IoT platform space. So they launch in reInvent, an event which they held at Las Vegas in last quarter of 2015. And they have an IoT platform named AWS IoT. Similarly, IBM Watson Bluemix is also available as an IoT platform. There is also Salesforce for IoT based on Thunder, which is better suited for enterprise IoT apps, where interacting with data from Salesforce ecosystem is important. Finally, there are many more platforms like Kaa, Kaaproject.org, Parse, which is from Facebook, the cloud application platform, Carriots, Tembu, and Particle.io, which are very new, and we will cover a little more details on these specific platforms, on three specific platforms, namely Kaa, Parse, and Carriots. Let me dig into three specific platforms in details. The first platform which we are going to go into details is Carriot. Carriot is a platform designed for quickly building IoT use cases. It has ready-to-use SDKs for prototyping devices like Arduino and well as Raspberry Pi, as well as for many industrial devices. It is better suited for tiny prototypes of IoT or for machine-to-machine application. It has support for REST APIs that can help access device data stream to a web or to a mobile application. Device management is available within the platform, which helps for easy plug and play of various devices, and it supports IoT application for scalability and flexibility when it comes to device management, monitoring, and maintenance. One can also utilize the rule engine built in and even use listeners and triggers that can provide alerts or send message to third party or to various stakeholders involved in the IoT ecosystem. Carriots can also be integrated with external IT systems through API, as an example, with third-party push notification service to send notification to various mobile devices. Now that we see the core components of IoT platform are very well implemented in Carriot, they are well suited for specific set of applications. However, there are some limitations also. Let's have a look at few limitations and also discuss the scenario most appropriate to use Carriot IoT platform. So in terms of limitation, there is not much support for data processing within the IoT platform of Carriot. One needs to write third-party cloud application and access data from Carriot with the help of API. Typically when there is a need for writing a complex business logic or for data processing, because there is limited support for data processing within the Carriot IoT Cloud. One can send the email and SMS notifications which are built into Carriot, but there is no built-in support for push notifications to mobile devices. So you need to integrate, say, a Google Cloud messaging or a third-party push notification service, which would be integrated to Carriot IoT platform. Another limitation which we observe that there is only support for Groovy language on the cloud development, and to some extent there is also support for curl, but not wide popular language like Java. Based on our experience using it for one of the application, we feel that Carriot is fantastic for smaller apps where you need to continuously monitor data from sensors or devices, and with minimal data processing, you need to alert or trigger some simple actions or send data back to the devices. Let me explain you one particular application where we have used Carriot. So we had an interesting case study where the problem was to achieve energy efficiency in a building by manually adjusting temperature of air conditioners. So what we did is a smart air conditioning where you can automatically set the temperature for an air conditioner which was HomeKit compatible. So we developed an IoT app which monitors the room temperature, monitors the external weather temperature, and based on this temperature, as well as taking care of the user preference, which could be customized on the Carriot dashboard. So based on this temperature and user preference, we send notification directly to the push notification by using the Apple push notification service, and that sends push notification to HomeKit compatible AC, and it sets the temperature. So there is no manual need of setting up temperatures, and thus we have built a smart air conditioning by just monitoring the sensors temperature from from various external as well as internal, and having some logic in the cloud, Carriot. And we have built like smart air conditioning system with a simple thing like there was internal sensor, external sensor. We wrote some logic in the Carriot cloud, which was not too much heavy. It was very lightweight, and the push notification is sent to the Apple mobile system, which then alerts the HomeKit, and the AC temperature is set. So this was very simple use case, and that's why we use Carriot. So as I said before, it is very fantastic for smaller apps where you need to continuously monitor data, and with minimal data processing, you need to send alert to something system. So that's just a quick revision of where we can use Carriot. Now let's jump into the next category of IoT platform, which is Parse. Of course, I missed to tell you. So some of the features which we use in Carriot IoT platform were data stream support, listeners, and email notification, and also third-party integration with Apple Cloud Messaging. The second IoT platform called Parse. So Parse was actually not invented specifically for IoT. It was actually initially developed for mobile developers, and it acts as a backend as a service for many mobile developers, so that developers need not worry about server-side coding and could build an end-to-end mobile application themselves. However, in the recent years, Parse has also released SDKs for embedded devices, and so embedded developers can now also develop end-to-end applications for IoT without worrying about writing server-side code. So Parse has cross-platform support, and there are SDKs for devices as well as mobile platforms like Android and iOS. They also have the SDKs for web applications. Also, there is REST API support. Parse SDKs are all open source, so one can extend the functionality as required. Unlike Carriot, Parse supports built-in push notification for both Android as well as for various devices, which saves significant development time. Monitoring device data or streams and also building analytics around the data is also one of the core and important components within the Parse platform. Parse provides support for easy user management and admin control. There is limited support for hardware platforms as of now, but it is very growing. So far, it supports Arduino, Raspberry Pi, and IoT devices from Intel, Texas, Atmel, but we don't see a lot of industrial system on chips supported so far within the Parse. On the other hand, Carriot supports a lot of industrial IoT chips. With this knowledge of key features of Parse, let's have a look at where it could be useful and what are some of the limitations for Parse. Major limitations which we observe is no built-in support for device management. We saw earlier in Carriot that device management is very plug and play kind of thing in Carriot, but in Parse you need to handle device management by writing classes in Parse. Second limitation is with regards to billing. Parse billing is completely dynamic, and users are charged based on number of requests served, and one must properly analyze number of requests per unit time required for IoT application and budget for appropriate monthly expenditure when using Parse infrastructure as an IoT platform. Within Carriot, it is a step approach for billing, so it was not much a concern. So you choose the plan which is right for you. The third limitation which we have observed in Parse is that push notifications sometimes get delayed. This should take due care of this when real-time action needs to be taken care, because in real time you might get these notifications like 10 to 15 minutes late also. Lastly, we have observed limitations on maximum number of objects returned via queries. So when querying the Parse database, you can typically get a max around like 1000 records at a time. So you need to program in that way. So with this knowledge, what we felt like Parse can be used for various applications, but typically a decent size small scale application. But yes, very much complete IoT application that necessitates moderate amount of data processing and analytics. Within Carriot, data processing support was limited, but in case of Parse, there is moderate amount of data processing which could be handled, and also there is a built-in analytics platform which is much better than what Carriot has. Let's have a look at case study for Parse. So we have been building for past 3 to 4 months a very interesting application called conference room booking. So typically within the enterprise, conference room booking are currently booked through calendars and not on actual usage. We have developed an application, IoT application for real-time conference room booking, which sends 3 kinds of data. One is live data within the conference room, the data from microphone within the conference room. If there is no people, there would be no voice. So of course we can say the room is available. Also we use motion sensors. So based on the 3 types of data, the signal from the light, the signal from the voice, and the signal from the motion, we detect whether the room could be available to use for some meeting or not. And based on this, we have developed the real-time application which can help developers or managers or admin people to book the conference room from the mobile app real time. So it's like an Uber for conference room. So of course, in this case, it was very difficult to use Carriot because there was limited support for data processing. So we had to choose Parse in this case. Lastly, we would like to update on use during this cloud real-time conference room booking. So we have written a lot of cloud code. It was significantly much higher than what we wrote in Carriot. We have written cron jobs to continuously sense which meeting will start, when it will start, when it should cancel based on push. And we have sent push notification to devices which are installed in hundreds of conference rooms deployed across various offices. So we have 3 offices here in Pune as well as 2 offices in the US. So we have deployed across various conference rooms which can get data and get availability of conference room for various developers. Let's dig into the third IoT platform, which is Kaa, which is kind of completely open source middleware platform for IoT. In Parse, the SDKs were open source, but in Kaa, the whole platform is open source and it is available for commercial, very suitable for commercial use also. Kaa platform can be hosted on the premise or it can also be deployed in the cloud like AWS or Rackspace or even Microsoft Azure. Or you could also choose to have a hybrid setup with some deployment could be on-premise, some could be on the cloud. With the help of Kaa, one can build a completely customizable end-to-end solution required for wide range of IoT applications. It has support for most of the protocols called HTTP, MQTT, COAP, XMPP, or even TCP for communication. There is a very strong event processing framework, and device management also is built in within the platform. It also has built-in support for push notification services. GKs are available for C, C++, or even Java, and it could easily support a lot of custom or even proprietary boards. So besides the regular standard boards like Arduino, Raspberry, which are like hobbyists or developer point of view, or even the industrial IoT boards, as well as even if you have custom built boards based on your requirement, that could also be supported using Kaa SDKs for devices. So it's kind of very holistic implementation for supporting a wide range of devices, wide range of protocols, and giving you complete flexibility. However, we have also found some limitations which we want to make you aware. They are not like strong limitations, but of course you should be aware when choosing Kaa. So one of the important thing is when choosing on-premise hosting, significant time is required for development environment setup and infrastructure. Even when you choose to deploy Kaa on cloud, there is moderate setup time involved. It is not plug and play like in case of Carriots. For each device, you need to create endpoint and integrate with Kaa ecosystem. Deployment and scalability needs to be handled with your IoT support systems when using Kaa IoT platform. Based on Kaa platform could handle custom IoT application development, especially when there is full-fledged need for building an end-to-end solution to integrate with custom workflows or even proprietary or existing database systems. It is also very apt to use Kaa platform when you are looking for an on-premise hosting and deployment. Say you want to have within your premise like intranet or within the hospital systems. We have used Kaa platform for smart hospital solution. So there was one requirement which we had from prospect, which was within the hospital system, they want an easy mechanism for the patients allocated in various hospital rooms to request help or assistance from nurse. So instead of, they wanted an automated way so that they can request for help or support instead of a traditional call bell system which is present in various hospitals. So what we develop is we develop an IoT application using Kaa which is deployed on premise in the hospital, so no one can access this from outside the hospital, and there are a lot of push buttons available beside the bed, so the patient can just push at the press of button they can request help or support from nurse. The nurse gets notification with all the patient details and the room number so that they can quickly attend the request of patient. All the nurses are wearing a wearable Android watch, and they get to see the patient name, details, and also the type of request. The features used for Kaa were on-premise hosting. We use event handling, push notifications to wearable devices. With this, I think we have covered 3 IoT platforms in detail. And of course, we would be happy to cover more other platforms in our future webinars. Now, before we try to go ahead for the demo, I think it would be interesting to even learn on the factors to choose IoT Cloud, and Sally would continue for explaining the factors in choosing IoT Cloud.
Thanks, Prashant. That was an insightful information where we could have detailed key features, limitations, and case studies on various clouds. So we have seen 3 kinds of different clouds. One is on-site hosting, then probably second, which we have seen with minimal data processing, and Parse was one which was at moderate level, where one could have data processing but not a huge kind of data processing. So that was really insightful. Looking at all this information, now let's see what all one needs to have a look for choosing the right IoT cloud platform for the application development. So the first factor to look upon is the cloud analogy. So as we have seen, there are different kinds of cloud available. Some is infrastructure as a service, some provide platform as a service, some are backend as a service. So one should look at all these analogies for deciding which platform to choose. This is because in case you are going to develop a small application where not much of data processing or devices is needed, then probably having infrastructure as a service is a better option, so that you don't do on-site hosting and save on infrastructure. Similarly, another thing to consider is the continuous connectivity. Unlike standard platforms, in IoT, there is a need for continuous connectivity as real-time processing is required. Diverse network will drive the success of the app, and hence continuous connectivity is necessary. So one cannot say that server is down for maintenance for 15 minutes or an hour or 2 hours. So even this needs to be taken care. Second factor is protocols. So supported protocols by IoT platform is also required. So in case devices connected in your IoT application has limited memory or supports only messaging, then probably MQTT is the right protocol for communication. But then IoT platform which you are choosing should also support communication via MQTT. So one needs to see which protocol, whether MQTT, XMPP, HTTP, or COAP is supported by the platform. The third factor is the capabilities that IoT platform has. So as we have seen, there are different key features in the three platforms which we have looked in the details. So in case, suppose your application depends on push notifications, then probably Carriot is not the right choice, as that would involve additional time or development time for developing the push notification service from scratch, and that too different for different platforms. So you need to code for IPNS for Apple notifications, Google messaging service for Android, and probably some other third party for embedded device push notifications. So push notification is a capability one needs to look at. Other capability is security or privacy. So in case you are developing any medical applications in healthcare domain, then HIPAA compliance to take care of. And if there are some cloud which provides such kind of security, of course there will be basic minimum security at all platforms, but if some platforms provide some special or rather advanced level of security, that would be of more useful. Similarly, IoT is still in its infant stage and it's evolving day by day, and so will your application as well. So one should be easily able to plug and play components to the existing system. Then may it be functional components or devices in the network. So scalability should also be present in the IoT platform. One should be easily able to scale the application whenever required, and also must be reliable to maintain the integrity of the system. So there are many such capabilities. According to the requirement of the application, one can figure out the capabilities and look those into the platform which one is going to choose. The fourth factor is hosting of your IoT cloud platform. So are you hosting on on-premise or private cloud can be option, or even hybrid or a mixed deployment is another option. So one needs to think on this as well. The fifth factor is the pricing. Pricing here is important because every IoT platform has different model for its pricing. Some platforms charge based upon number of connections or number of devices connected. Some charge based on bytes transferred over the network. Some charge based on number of requests per second, per minute, and sometimes there is monthly rental. Also some charge based upon the storage you have done on the cloud. So pricing is another important factor to consider. Then last is the supported platforms. So as IoT has heterogeneous devices, one needs to think whether the platform supports the hardware which you want to build upon. So maybe Arduino, Raspberry Pi, and mobile devices. So these are the factors that needs to be considered. Now that we have looked on the factors, let's have a look at demo that we have built in the Harbinger here. So we have, Prashant has already explained you the conference room booking application. So let's have a look at demo. So here we have Android application. one logins to the application and see the list of rooms available. Here you can see the complete time slot is available for booking. So we select the conference room C and book the conference room from 1700 hours to 1800 hours. Fill in some details as the title or the project details, then some description about the application, and thus book the conference room. Now if you see the list, then 1700 hours to 1800 hours is not available for booking. Once clock ticks 1700 hours, it will start sensing the data from the Arduino board. So here you will see the Arduino board which has sensors installed on it. So you have motion sensor, light sensor here, and then it will collect the data for 5 minutes. And based upon the algorithm design, it will decide whether meeting has commenced or not. You can see the red color LED and it's not glowing. This indicates that meeting is not commenced and hence it will get cancelled. So on Android phone, you get a push notification saying that meeting has been cancelled. So if you go to the application again, you can see the conference room C is available again. So this is the demo application which we have built at Harbinger. So let's go to the presentation again. So let's summarize what we have seen till now. So here you can see the graphical representation where we have compared the 3 platforms we have seen based upon the flexibility, customizability, implementation efforts, cost, and time to value. So we have studied earlier these factors, and here is a quick snapshot that shows that Kaa supports most when it comes to flexibility, custom IoT workflow, while Carriots is more suited for usual use cases like IFTTT or monitoring some data of machinery on continuous basis. Parse is somewhere in the middle where compared to Kaa and Carriots. So as we have seen in the case studies, demos, and so far discussions, different IoT platforms have different key features. There is no single platform that supports most business needs. Some platforms have built-in support for push notifications, some have strong analytics, or some have good support for device management. Depending on what are the requirements for your application domain, one need to wisely choose appropriate IoT platform. IoT platforms are very helpful for rapid development as they take care of the IoT of core functionality. Developers can concentrate on 100% of its business logic and domain instead of dealing with common IoT models, and even be educated about the best practices in the industry. So to conclude, IoT platform help for developing cost-effective solution to your business requirements. So this ends our webinar discussions. Now the moment all they're waiting for is special offer. We have a special offer for all the webinar attendees. First, send folks to request consultation on specific technical challenge related to IoT shall receive 2 weeks consultation over the email, and one lucky attendee selected in a blind selection, of course, gets hands-on support from a developer for a week. Write to us at hsinfo@harbingergroup.com to avail this exciting opportunity. Now, Now we'll take the question and answers. I remind you once again, if you have any queries, please type in the questions pane. Due to time constraints, we are not able to cover any of your questions in today's session. We'll definitely send you the Q&A document covering answers to all the questions raised today. So I can see many questions coming in. And let's start with the first one. So the first question is, are there any even simpler or minimalistic IoT middleware catering to Amazon dash button kind of use case for an e-commerce company? So yeah, I would request Prashant to answer.
Yeah, I think if you are looking for something like Amazon dash button kind of use case where you push something and you get some request whether they want some product or something, I think it would be interesting. Of course, we have not covered one of the IoT platform which could be good, because for this kind of use case there is the internet button. If you go do a Google search on internet button, you can see one of the board from spark.io. Of course, they have renamed to particle.io. So they have a ready device which you can use for internet button, and particle.io is a cloud platform which we haven't covered in today's webinar, that for this kind of button like IoT ideas. So of course you could use Kaa also. So Kaa is also good to use for this, but I think particle.io might be better in case you are a startup and looking to create hardware prototype also, because internet button is built-in support. So that's it. We have some more questions. So there is one question which is on Carriot. So let's take up that. Of course, we have more questions, but it would be good if we can cover questions based on the platform which we have already discussed. So can you please show us how simple or how easy it is to use Carriot platform? Maybe,
okay.
Shaili, why don't you log into a Carriot platform and show something, maybe adding a trigger or alert?
So let's go to Carriots. I'm just logging to Carriots. So here on the left hand side you can see the project. Here if you see Smart AC is the project which we have developed. Then each project had some of the services. So we have services for different buildings. And in buildings we have groupings floor wise. In that grouping we have devices. So we have AC at first floor in GP. So this is the hierarchy which we have created, and now we'll see these are the device details. So let's see the data collected for this device. So if you see here, continuously getting calculated. So if you see the date, it's 13 January, 21 hours. So we'll just see the listener which we have added for this. We have AC listener. Here if you see, if the temperature is greater than 87, the mail is sent. Now that what is the current value? So it's around 83. So if I just change the threshold value here, so probably I'll say if it's okay, let's edit this. If I say if it is greater than 82, then send a mail. We'll go to database again and just, so we'll just log in. We'll just log into the email account where mail is sent. Let's change the email ID probably. If you see, we have got an email notification. So this
That's fantastic, Shaili. I think it was good to get all the temperatures in my email account so fast. I think I'll be flooded with a lot of email account. Could you please first disconnect the listener so that I'm not flooded with email account, a lot of emails from Carriots?
Sure, Prashant.
Or you could just increase the temperature to 87. So it was fantastic to see the live continuous triggers from our room, from the which is connected to Carriots.
Once again, I remind you of the special offer. We have a special offer for all the webinar attendees. First 10 folks to request consultation on any specific technical challenge related to IoT shall receive 2 weeks of consultation over email, and one lucky attendee selected in a blind selection gets hands-on support from the developer to 1 week. So today's webinar is being recorded, and everyone will receive an email with a link to view the recording of the event along with the Q&A document. With this, we conclude today's session. Once again, thank you all for joining us and have a great day ahead.